For this lesson, we want to work on solving systems using graphing to see it visually and see what the solutions are. So our objective is to solve systems using graphing. So first of all, we want to define what a system of equations are. So first of all, system of equations that's two or more equations. Now these equations usually, when we put two or more equations together, we can look for solutions. Usually at the beginning here, we're going to just talk about two equations. Later on, we'll look at some differences to that. But for now, two equations. When we're looking for solving it by graphing, you're looking for the intersection. So the solution is the intersection of the graphs. Now, we'll talk at the beginning here about, I'm going to illustrate this with a linear system. So a linear system is when you've got the graph of two lines. So we're going to have two lines, and there's three possibilities for that. When you have two lines, one possibility is to have intersecting lines, meaning that if we graph one line like this, and we graph the other line like this, you have that answer where they cross as the solution. So there would be one solution here to where they cross. Okay, now what if instead you were to graph one of them and you graphed it like this, and the second one that you would graph would instead go right on top of it. So not only would you have the first graph, but the second one would go right on top of the first one. In essence, you have two equations in different forms. They end up being the exact same line. Well, if we have that, this ends up being that you have an infinite number of solutions. The infinite solutions are really the entire line. This is that ordered pair right there is the solution, the one solution. This is the entire line is the solution. And this line has an infinite number of points on it. Well, this last possibility for two lines is if you draw one line, and then you draw the second line, and they're parallel. Well, notice those two lines never intersect. They have the same slope. So since they have the same slope, they have no solution. Okay? We sometimes will call that inconsistent. Make sure we see that. So inconsistent. Now let's turn our attention to a couple examples of this. We're looking at two equations. They're going to be linear equations. We're going to look at how they interact as lines. So first of all, let's do this first one. These problems, I'm going to get them into slope-intercept form because I'm used to doing those that way. So let's take this one. I'm going to take it and make it into y equals mx plus b. Remember, with slope-intercept form, we've got our y-intercept and our slope to graph them. So let's take this first one, x minus y equals 5. I'm going to subtract x from both sides, and I'm going to write it first because that negative x, I want to have the mx plus b to be first. Then I'm going to multiply or divide both sides by -1. There's a -1 in front of that y, So divide every term by -1. This one's going to be a positive x then, and this will be a -5 in order to get that. Let's graph this one. So start at -5. You're going to start right here. And our slope here is 1. So I'm going to make that either 1 over 1 or -1 over -1. So if I go up 1 over 1, up 1 over 1, etc., there's my graph. I'm going to draw a line through that. So my line will go straight through these. Okay, right through there. Okay, so there's my line. Now, the next one I'm going to do is this x plus 2y. Let's make that a little smaller. Okay, so x plus 2y, change it here, equals -4. I'm going to go ahead and subtract the x again to the other side. So 2y equals -x minus 4. And then I'm going to divide every term by 2. So this can be a y. If I divide this by 2, I'm going to get a -1/2 in front. And then -4 divided by 2 is going to be a -2. So this one I'm going to start at -2. Let's do some in green to start for the points. So at -2 here. And then I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. And I'm going to draw a line here. So this one will go like this through there. And as you can see, when those two are graphed, our solution is this point right there. That's the solution to it. So my ordered pair answer will be 2, -3 for a solution. Now let's double check that. What that means is it should go into here and be correct. So if you put in 2 for x and -3 for y, 2 minus -3 is 2 plus 3, or 5, that works. Let's put in the second one, 2 plus 2 times -3 is -6, 2 plus -6 is -4. That's the solution to those two. All right, so that's solving a linear system using graphing. Let's do this one. I'm going to again get these into slope-intercept form. So I'm going to take the first one here, x plus y equals 7. I'm going to go ahead and subtract x from both sides. So you get -x plus 7. And so if I graph that, I'm going to start at 7. So here's my 7. I'm going to use a slope of -1. That's either -1 over +1 or +1 over -1. Those are my two choices. So if I go down 1 over 1, down 1 over 1, and then draw my line, looks like that. Okay, let's do the other one. So we'll do this one in blue. So that's 2x plus 2y equals 2. Subtract 2x from both sides, so you get 2y equals -2x plus 2. And if you divide everything by 2, you get y equal to -x plus 1. So this says start at 1 and then go down 1 over 1. Same slope, notice, so it gives me that same slope look. Or draw a line, that's going to be it's right through there. Now if you look at those two lines, they're parallel. There's no solution to this one. So as we do this one, no solution, because the two graphs are parallel lines never intersecting. So to solve a system of equations using graphing, a system is where you have 2 or more equations. The solution is the intersection of the graphs. If you were to do linear systems, your 3 options are that they intersect in one point, that they are the same line, or that they're parallel and that there's no solution. So we take a look at what the graphs are, look for their intersections, and that will be our solution.